Welcome to the AI Research Roundup. I'm Alex. Today we're looking at a paper from the Hugging Face trending list, published on February 26, 2026, just 2 days ago. It introduces a hybrid reinforcement learning framework that yields a massive 129% performance jump on the Science World benchmark compared to prior methods. The paper is titled Exploratory Memory Augmented Large Language Model Agent via Hybrid On and Off Policy Optimization. And as we'll see later, the implications for agent adaptability are quite significant. Figure 1 illustrates this performance gap using learning curves and benchmark comparisons. On the left, panel A tracks the return on a Science World task, where the blue line for EMPO2 rises steadily to solve the problem, while the purple line for the group relative policy optimization baseline stays flat. Moving to panel B, the bar charts show a massive 129% improvement on Science World for in-distribution tasks. Finally, the charts on the far right demonstrate that EMPO2 also adapts better to out-of-distribution tasks, maintaining positive returns where the baseline often fails. To understand where EMPO2 fits, Figure 2 maps it between two paradigms. The blue circle on the left represents non-parametric approaches, like reflection, which rely on external memory without changing weights. Conversely, the purple circle on the right covers parametric methods, like proximal policy optimization, that optimize parameters directly. EMPO2 sits squarely in the intersection. The red arrow labeled boosting shows the core mechanism. Memory-based exploration discovers new strategies, which then bootstrap the parametric updates to lock in that knowledge. So, Figure 5 details the learning process, broken into 3 modes. On the far left, we see standard learning without memory. The agent acts on the state alone, but generates tips to populate the database. In the middle panel, the agent retrieves those tips to guide its actions and uses them during training, teaching it to follow advice. The real trick is on the right, in the off-policy mode. Here, the agent uses tips to explore successfully, but the update step hides those tips. This forces the model to learn the correct behavior from the raw state, effectively internalizing the external knowledge. So, Table 1 details performance across 19 Science World tasks, from chemistry to electricity. The columns compare EMPO2 against baselines like reflection and group relative policy optimization. Looking at the bottom row, the naive model struggles with a negative score of 61, and while other methods reach the positive teens or 30s, EMPO2 achieves a remarkable average of nearly 76. It even hits a perfect 100 on several classification and biology tasks, showing it effectively internalized the exploration strategies. While Table 1 showed static performance, Figure 8 demonstrates how quickly the agent adapts to completely new tasks. The columns represent different transfer scenarios, like moving from biology to electricity, while the x-axis tracks progress as the agent accumulates memory over trials. Looking at the top row, EMPO2, shown in blue, rapidly improves its score, gaining nearly 178% in the electricity to chemistry transfer on the far right. Conversely, the bottom row shows that group relative policy optimization, in purple, struggles to leverage new experiences effectively, often remaining flat or erratic. This proves that EMPO2 effectively uses memory to explore and master unfamiliar environments. While Figure 8 demonstrated adaptability in science, Table 2 extends the evaluation to the web shop benchmark. The columns compare EMPO2 against baselines like the offline retrospects and the online GigPo models. On the left, non-parametric methods struggle, topping out at 58. The online RL methods in the middle improve this significantly, with GigPo reaching 86.2. However, the final column shows EMPO2 takes the lead, achieving a score of 88.3 and a success rate of 77%. Wrapping up, 2 takeaways stand out. EMPO2 effectively bridges the gap between temporary memory and permanent learning, allowing agents to internalize successful exploration strategies. This suggests a future where models adapt rapidly to novel environments without relying on static prompts. That's it for this episode of the AI Research Roundup. I'm Alex. Thanks for listening.